In this video, I'm going to explain the properties of the definite integral, and I'm going to solve some exercises about them. Here, the properties are given. The first property, if the boundaries are same, the integral of the function, it should be equal to 0. I give one simple example for only this one, like the integral of x squared. We know that, x is equal to x squared over 2, and x squared over 2, we are going to write the boundaries like from 3 to 3. So the answer is going to be equal to 3 squared over 2 minus 3 squared over 2, which is equal to 9 over 2 minus 9 over 2. That's equal to 0. Here I can give a lot of example for each of the exercise, but we already practice about this kind of things. That's why I'm going to explain only, and I'm going to skip this part. Here, from a to b fx dx, when you change the boundaries, you should put minus sign. And for the third one, the coefficient is not important. So you may get the coefficient in front of the integral. Is not important doesn't mean we are not calculating, only it's not changing the integral result. When you have the boundaries, it allows to add and subtract the two different functions. Here the fifth one a bit different than each other. If you place a number between a and c, like b, here, then from a to c, integral, it will be equal to a to b plus b to c. A to b, then b to c. Okay, let's solve some exercises. This is the practice of the fourth question, fourth property. Here there is addition and subtraction sign. As you know from the integral, indefinite integral, we are going to do the same thing only. First, I'm going to get the integrals of them. Integral of 2x squared is equal to 2x cubed over 3. The integral of 3x, it's going to be equal to 3x squared over 2. It's going to be, and integral of 4, it's going to be equal to 4x. The boundaries are 1 to 3. This means that first we are going to replace by 3. 2 times 3 cubed over 3 plus 3 times 3 square over 2 plus, actually it is minus 4 times 3. These are all plus, minus the second value. 2 times 1 cube over 3 plus 3 times 3 square over, 1 square over 2 minus 4 times 1 is going to be 3 cube is 27 times 2, it's equal to 54. 54 over 3 plus 3 times 3, 9, then times 3, it's equal to 27 over 2 minus 12 minus 2 times 1 over 3 is equal to 2 over 3. 3 times 1 over 2 is equal to minus 3 over 2, and minus 4 over 4 times 1 is equal to minus and minus plus 4, it's going to be. So 54 over 3 minus 2 over 3 is equal to 52 over 3. Plus 27 over 2 minus 3 over 2 is equal to 24 over 2. Minus 12 plus 4 is going to be equal to minus 8. 24 over 2, it's going to be equal to 12. And here it's going to be equal to 52 over 3. 24 over 2 is equal to 12 minus 8. And 52 over 3 plus 4, that's equal to 3 times 4, 12 plus 52, it's going to be equal to 64 over 3. Okay, the next question. Now, for this question, we are going to first get the integral of e to the power of 3x plus 1. E to the power of 3x plus 1, you remember 1 over e to the power of ax plus b is equal to 1 over e to the power of ax plus b plus c it was. But here in indefinite integral we are going to get only 1 over 3 times e to the power of 3x plus 1 from 0 to 1. It's going to be for us 1 over 3 times e to the power of 3 times 1 plus 1 minus 1 over 3 times e to the power of 3 times 0 plus 1. It's going to be, that's equal to 1 over 3 times e to the power of 4, and here 1 over 3 times e to the power of 1. The answer is going to be equal to e to the power of 4 minus e to the power of 1 over 3 going to be. Then for this one, here we learned the radical function, how to get the integral of the radical function. Now we are going to get the definite form of the integral from 0 to 1. From 0 to 1. And if you remember, the method was 3x plus 1, we were substituting by u, then 3x plus 1 square, it should be equal to u square. Then if you get the derivative, this is going to be 3 dx is equal to 2u du, and dx must be equal to 2u du here over 3. Here, most important part in indefinite integral, also you may substitute the values here. What I mean, if, this is the important part, if x is equal to 1, I'm choosing these values. If x is equal to 1, and if x is equal to 0, what is the u value? U is equal to what? U is equal to what? U is equal to square root of, if x is equal to 1, it is 3 times 1 plus 1, which is equal to root of 4, which is equal to 2. So it means that if x is equal to 1, this implies that u is equal to 2. When you substitute, instead of x is equal to 1, you may write u is equal to 2. If x is equal to 0, then u is equal to 3 times 0 plus 1, which is equal to root of 1, because 3 times 0 is equal to 0, then the answer is going to be equal to 1. Here, if we get the integral by using these substitutions, integral 0 to 1 square root of 3x plus 1 dx, it's going to be equal to, from 0 to actually 1 to now, because after u substitution, this becomes 1, 0 becomes 1, 1 becomes 2. And instead of square root of 3x plus 1, we are going to write u, instead of dx, 2 over 3 u du. So this becomes integral 2 over 3 can be written firstly 2 over 3 integral 1 to 2 u square du. Integral of the u square is equal to u cube over 3, 2 over 3 u cube over 3 from 1 to 2. This can be written as 2 over 9 u cube from 1 to 2. So first I'm going to substitute by 2 over 9 times 2 cube minus 2 over 9 times 1 cube is the answer. 2 cube is equal to 8 times 2, 16 over 9, minus 1 cube is 1 times 2, it's equal to 2 over 9. The answer is going to be equal to 14 over 9. This type of questions we are going to solve by using integration by parts. So it means that we are going to use L'Hopital rule here. And if you remember, we said the ln x was the logarithmic function and x was the polynomial function. And if we substitute the values here, ln x is equal to u, it's going to be, and the rest of them x dx, it must be equal to dv. Here derivative it's going to be 1 over x dx is equal to dv. Here it's going to be integral, so x squared over 2 is equal to v, it's going to be. If we write the formula, integral u dv is equal to u times v minus v du, it's going to be, firstly I'm going to arrange this one, integral 1 to e x ln x dx is going to be integral 1 to e u dv form I'm going to write, which is ln x times x dx, because I'm going to replace ln x times x dx here, ln x times x dx, which is a question, is going to be equal to u times v, u is equal to ln x times x squared over 2. These are already integrated, that's why we may write 1 to 2, 1 to e, sorry, or let me write at the end, integral v du, and that's equal to v is equal to x squared over 2 times 1 over x dx, it's going to be, then it's going to be equal to from 1 to e, then it's equal to ln x times x squared over 2 minus, if you simplify x squared and x, and if you get the 1 over 2 in front of the integral, the result will be integral 1 over 2 integral x dx from 1 to e, and that's equal to, that's going to be equal to ln x times x squared over 2 minus 1 over 2 times integral of x is equal to x squared over 2. It's going to be, the boundaries are 1 and e, it must be. Then if I continue to solve this one here, ln x times x squared over 2, sorry for the sounds, but we are cleaning the school now. Ln x times x squared, I'm going to replace by e firstly, that's the way it's going to be like this, ln e times e squared over 2 minus 1 over 2 times e squared over 2. This is the first boundary when you give e. That's the second one, is equal to ln integral ln 1 times 1 squared over 2 minus 1 times 1 squared over 2. It's going to be 1 over 2 times, sorry, 1 over 2 times 1 square over 2. Then it's going to be equal to, here, this expression, it's going to be equal to 0. That's why it's going to be completely 0, this expression. And here, this one is going to be equal to 1. So the answer is going to be equal to e squared over 2 minus e squared over 4. And here it's going to be equal to plus, because here minus, we have minus and minus, it's going to be plus 1 over 4. Then here if you multiply by 2, 2e squared minus e squared plus 1 over 4. The answer is equal to e squared plus 1 over 4 is going to be.